Okay, so this project, in its finished form, whatever that ends up being, needs to fit in my X-Tool laser. I'm simply just going to make the project fit within the dimensions that I can fit in here. So I'm going to basically do that off of the grate. So it looks like the grate's measurements, assuming they're accurate, gives me a 320 by 510 millimeter max. So we need to go find a piece of maple or lighter colored hardwood that is as wide as possible, up to 320 millimeters and 510 millimeters for this project. I'm pretty excited about this project. Okay, so I found this piece of maple. It's decently wide. So this is about 260 millimeters wide. We have room for wider, but this is a decent looking, relatively flat board, 3/4 or 20 millimeters thick. This will work for our project. So I'll cut off about 625 millimeters, and we'll work with that. So now that we have the overall dimensions and wood piece, we'll create a CNC job. So we'll do 600 millimeters for the width, 250 for the height, 18 millimeters for for the thickness, and XY origin on the corner, and single-sided. Then we'll go import some vectors. This is the design, the inlay, and the outer cutting. This was done in Adobe Illustrator. So we'll select all of them briefly and group. And then we're just going to center this up on the material piece. And then we'll ungroup. What we need to do is adjust the hearts that are going to be the inlay model to be pocketable. And so we'll use a 1/8 bit. So what we're doing here is fixing the vectors, which are curves, so that we can do a fillet of 4 millimeters, which will be large enough. So we use the node tool. And you'll see this is a continuous curve. What we'll do is we'll add a point, and then we'll convert each side to a line. This is kind of a fix on Bezier curves in order for you to be able to fillet them. And so then we can pick the fillet tool, click 4 millimeters, and then you see it'll smooth it out. So we'll go to this one as well. You can see you can't fillet. So we go back to the node edit tool, and we'll add a point just like before, and then change the arc to a line between our added point and the 2 other points, and then apply the fillet. And to make sure that that's all we need to do, I'm going to go ahead before I do the other hearts and do a profile path with the bit that we're going to use. And then you can see when we turn on to see the tool path and what it cuts, that we have no gaps from the vector and what the tool path can run across the whole heart. That way we know we can cut it out, the inlay out, and we can cut the pocket out, and they should fit. And so we'll just repeat that with the other 2. So use node edit tool, insert a point, change between the 2 points of the arc and the point we added to be lines, and then do our 4 millimeter fillet. You can see here, at first it looks like it'll do it, but and you can see it doesn't actually, so we got the same deal. And so when you click it with the node edit tool, you can see, so at point, change the segments that are curves to lines. So we'll double check it by including this vector in the toolpath. So we look good on that one. And here you can see the issue here. And again, even on the bottom of the heart, the angle is too sharp. It's fine because it's an outside profile path here. But we also have to do that same path as an inside profile path. So we have to make sure that the angles are no sharper than what a 1/8 inch bit can do. So we make sure to fillet them at 1/8 of an inch or greater. So 4 millimeters is slightly greater. So just doing the same thing. You can see how much that smooths out. So we just recalculate tool paths. Okay, so then we select the 3 hearts vectors that we've fixed the fillets for. And here I'm exporting them as SVGs. And then in Fusion, I'm importing them. And so then on import, I'm just moving them close to origin. Doesn't really matter. And then I just finish sketch. I know I want these to be 9 millimeter thick, so I start to just extrude. And then what I'm noticing here is, so the proportion didn't look right when I excluded the 9 millimeters. I wasn't really paying too much attention, but it looks like scaling is off. So what I'm doing is I'm just going to add a couple construction lines to just give me a very quick measurement reference so that I can have an idea of accurate scale for my intent. I'm just making 3 lines from origin, roughly the distances of the hearts. And so then I pick the largest one, and I can then go back to Aspire and roughly measure the same. And I see that that measurement's about 77 millimeters. Which is compared to like 25 or something, or 21 in Fusion. So I definitely have a scale problem. So instead, I'm exporting it as DXF. and then importing as DXF. The two vector formats that Fusion and Aspire will do that are common. And so it seems like SVG was losing unit of measure in the scale. And so you can see the DXF is much larger. So I'm just doing the same thing again. Just making a construction line that's roughly the same as what I can measure in Aspire. Just a cross check. So this construction line is 77 millimeters. So that's pretty much what Aspire is. So the DXF is holding appropriate dimensions. Again, this isn't precise, but it's in the ballpark. So I'm pretty sure I don't have a scaling problem. So now I'm going back and extruding to 9 millimeters. And the key here is when I'm doing it, I'm telling it to create a new component because I'm going to make changes and I want history per heart. And it's just easier to use components and have individual body histories. So then once I did that to all three, I'm just naming them. And then I'm selecting one of them and making sure it's active. And then I'm doing a 2 millimeter shell. So this cuts out everything that's a 2 millimeter wall and a 2 millimeter bottom. And I'm doing that because I want, to make a bowl effectively. But as you can see here, and I'm showing, these are pretty segmented vectors. And so like doing a fillet is cumbersome. So instead, what I'm doing is I'm going to project the body as a sketch onto the 2 millimeter above the bottom, after the shelling it out. I'm doing that here where I'm picking the body to project. So now you see this very complex curve vector. So then I selected for the offset, and then I bring this offset in to my desired scale. I think on this medium one, I decided that 12 millimeters looked pretty good. So now I have a sketch in this component. That sketch is a sketch that includes the body's outer perimeter and an offset, and it's 2 millimeters off the bottom, so it's on that face from the shell. So then I'm going to go back in the timeline for just this component, which is why it is a component. And I'm actually going to delete the shell. No complaint about it. or it'll give you a warning. And so now I'm going to turn off the body, get that inside component and then the top outer component, and then we're going to do a loft, and this makes a bowl, a pretty complex but smooth. And so then I'm just going to repeat that whole process for the other two hearts. So effectively we'll be pocketing out 9mm on our main board to put these inlays. And these inlays will be 7mm deep from their top surface to their bottom, with 2mm of solid. And so then to make sure, I export one of these models as an STL, and then I'll go import the model for the 3D printer. And this is a relatively quick way of making sure that what I want and how I think it'll look lines up before cutting into good hardwood. So I'm just picking up PLA. And I send it to the printer. And I print.